Alright, today we're talking about 3.4, which is arc length and area of a sector. So we're going to come back to this formula, S equals R times theta. Now we get that from the formula we talked about last lecture that said that theta equals S over R, where theta was measured in radians, S was the length of the sector, and R was the radius of the circle. So we just rearrange that by multiplying both sides by R. My R's cancel, and I'm left with S equals R times theta. And the important thing is theta has to be in radians. So let's do an example of this. Find the length of the arc cut off by a central angle of 3 radians in a circle of radius 5.4 centimeters. So I like to draw a picture right away. Draw my central angle theta. Alright, so we know the radius, right? We know the radius is 5.4 centimeters. And we know the central angle is 3 radians. But we want to know the length of the arc. So plugging into my formula, I want to find S. I know R, which is the radius, 5.4 centimeters, times theta in radians. Remember, theta and radians have absolutely no units, so I just multiply by 3. Multiply that out, we get 16.2 centimeters. Now, if radians had units, we would have to tack that on at the end of the centimeters. However, that wouldn't really make sense because we're talking about length. So it makes sense that we only have centimeters at the end. Let's do another example, this one a little bit more applied. The minute hand on a clock is 1.5 centimeters long. How far does the tip of the hand move in 20 minutes? We're going to assume that the hour hand here doesn't move. On a normal clock it would move slightly. We're going to assume it stays right on 12. So we know the minute hand is 1.5 centimeters in length. Now we want to know how far does the tip of the hand move in 20 minutes. If we want to go back to our formula using the S equals R theta formula, well, we need to know radians. We need to know what my central angle is. So we're going to use the fact that a full revolution around a clock would be 2 pi, or 360 degrees. Now we're going to chop it up into twelfths for each number on the clock. So for each number, so from 12 to 1, from 1 to 2, from 2 to 3, right, there are 12 of those sectors in this circle. So I'm going to divide by 12 to figure out the theta in radians between each number. Well, 2 goes into 12 6 times. So between each number is pi over 6 radians. Now we're going from 12 to 4 in 20 minutes, which means we have 4 of the sectors. So I know then that the central angle is 4 pi over 6, or 2 pi over 3 when we reduce. So the central angle here is 2 pi over 3 radians. Now we're going to plug everything we know into my formula. S is equal to R, the radius. I know that's 1.5 centimeters in length, times my central angle, or 2 pi over 3, in radians, so there's no units. Simplifying that down, we get pi centimeters. Now it's important to remember that's the distance it travels around the outside of my circle. So we're going to introduce a new formula, the area of a sector. So if we have a central angle theta again, and a radius of r, the area of that green sector is 1/2 r squared times theta. Remember, theta has to be in radians again. So let's use this formula to figure out some problems here. Find the area of a sector formed by a central angle of 2.5 radians in a circle of radius 10 centimeters. Let's draw another picture. Remember, I have my central angle, and it tells me my central angle is 2.5 radians, and also that the radius of the circle is 10 centimeters. So let's plug everything into my formula. A is equal to 1/2 times r squared. I know r is 10 centimeters. All of that squared. Times theta, which is 2.5. And remember, radians have no units, so I'd just tack on a 2.5. You can simplify that down. 10 squared is 100, divided by 2 is 50, times 2.5, which comes out to be 125 square centimeters. So that's the area of this sector that I'd cut off. Okay, another problem. If a sector formed by a central angle of 15 degrees has an area of pi over 3 centimeters squared, find the radius of the circle. So your initial thoughts would be to just plug it into the formula. Remember, this central angle is measured right now in degrees, and we need it to be in radians. So we need to use that conversion factor of pi over 180 to switch from degrees to radians. So I'm going to multiply 15 by pi over 180. 15 goes into 180 12 times. So my radian measure of 15 degrees is pi over 12. Now with that, I can plug it into my formula. So I get that A is equal to 1/2 times r squared theta. So let's plug in everything I know. I know the area. I know A as a pi over 3 centimeters squared. That's equal to 1/2 times, I don't know the radius. That's what I want to find. So I'm looking for r, so I put in r squared, times theta, which I know as pi over 12 radians now. So I'm going to multiply both sides by pi over 12. By 12 over pi to cancel. So on this side, pi's cancel, 12's cancel. On the other side, pi's cancel. 3 goes into 12 4 times. So on one side, I'm left with 4 is equal to 1/2 r squared. I can multiply both sides by 2, so I get r squared is 8. And I have to square root both sides. So I'm left with r is equal to plus or minus the square root of 8. However, does it make sense to have a negative square root of 8 as a radius? No, because we're dealing with a length. So we only deal with the positive side. So we get r is equal to the square root of 8. It's always important to, after you're done solving, to go back and look. Do my answers make sense? If I have two answers, I should check both of them to make sure both work. In this case, the negative one didn't work, so we threw it out. In this last example, a lawn sprinkler located at the center of a yard is set to rotate through 90 degrees and project water out 30 feet. To 3 significant digits, what area of the lawn is watered by the sprinkler? Well, let's just kind of write down everything I know. I know that this is a 90-degree angle, so I put my box in. And I know the radius is 30 feet. Well, I know a degree measure, but I need to know it in radians. Now, we can either go through the conversion factor, which we'd multiply by pi over 180, or hopefully we've memorized our commonly used radian measures in degree table now to know that theta is going to be pi over 2 radians. If not, we can go through our conversion factor. So we take 90 times pi over 180. 90 goes into 80 twice, so I'm left with pi over 2. That's how we get pi over 2 radians. I also know that radius is in 30 feet. Alright, let's just plug in everything we know. We want to know the area. So A is equal to 1/2 times r squared. I know r is 30 feet squared times the radian measure of pi over 2. We can plug that into our calculator. We get 225 pi feet squared. But this pi feet, but 225 pi, I really don't know what number that is. So we would plug that into our calculator again, and it comes out as 707 feet squared. Now that is 3 significant digits because we count starting from the left, and we get 3 digits. So we don't have to go any more than just 707 feet. Alright, go ahead and write your summary and any questions you have, and then take a peek at the homework before tomorrow. Come with questions, and we will hopefully get them answered.